Hello, my name is Joshua Mendoza, and I'm here to do problem 13 of the VPT problems, which is SI n minus. Alright, so let's get started. So first we must draw the Lewis structure. So we must determine how many valence electrons are in this compound. So we know that silicon has a total of 4 valence electrons. We add that to nitrogen's 5 valence electrons. And since the compound is negatively charged, that gives us one more valence electron, which gives us a grand total of 10 valence electrons. So now that we know that, we can draw our Lewis structure. So we're going to have silicon right here, triple bonded to nitrogen. We're going to have one lone pair next to the nitrogen, and another lone pair next to the silicon, giving us a grand total of 10 valence electrons. But since we know that this compound is negatively charged, we must show that by drawing brackets indicating with a negative sign indicating the negative charge. So now let's move on to the Bessemer structure. First, we need to determine both its molecular and electrical geometry. Since this compound we know is linear, it's going to be the same for both. So let's write it linear right here. I'm going to box that. And then it's very similar to the Lewis structure. We're going to draw an Si again, triple bonded to the nitrogen. We're going to have one lone pair here, and another lone pair here. We're going to bracket this again. But now we're going to draw its angle, which is 180 degrees. Alright, let's move on to the next part. Alright, now it's time to do the electron box diagram. So let's first start with Si. Si in its ground state fills its s orbital completely. So we have one electron here, 2 electrons. And then for its 3p, it's going to have 1, 2. But since this compound is negatively charged, we're going to add one more to its p orbital. Okay? Now, we're going to be circling the s and the p orbital. But specifically, we're just going to be circling this right here. Now, these electrons I just circled are going to get hybridized directly. We're not going to have to excite anything. No need to waste energy. We're immediately going to go from ground state to bonded state or hybridization state. So let's go and add these electrons now. So it's going to be 1, 2, 3 electrons. Okay. And then we're going to add the remaining p orbital electrons from Si. So we're going to have 1, 2. Okay. We're not done. Remember, we must add this arrow and we must write hybridization. That's very important. Okay, let's come down to now nitrogen. So we're going to have 2, and its s orbital, it's going to fill it completely in its ground state, and then let's move up to its 2p orbital. We're going to have 1, 2, 3. Okay, same as before, we're going to circle the s and p orbitals, but just 3 electrons. These 3 electrons are going to immediately get hybridized. No need to excite any electrons, promote, or add energy. And we're going to then have 1, 2, 3 electrons right there. And then let's add the rest of the electrons to its p orbital. So 1, 2. Okay, cool. Now, let's go on to the bonding. So we're going to have a bond right here. And this is going to be a sigma bond. Okay? Now, we're going to have a bond between the p orbitals, and these are going to be pi bonds. So we have a total of 2 pi bonds and 1 sigma bond. And we have our 2 lone pairs. Okay, perfect. Now let's move on to the next part. Alright, now time to do the final part, which is drawing the contour diagram. So since our compound is linear, we're going to draw a straight line like I've just done. So now we're going to draw silicon right here, nitrogen right here, and now we have to show the bond between the silicon and the nitrogen. So we're going to draw one sp orbital and another sp orbital. This is going to show that these two elements are bonding, so we're going to have to draw sp in here, sp, and then we're going to have to draw electrons in the middle of the overlap to show that these two are bonding. Now to show the lone pairs, let's go over to nitrogen. We're going to draw the same sp orbital. We're going to draw sp right here. And then we're going to put 2 electrons showing the lone pair. And we're going to do the same thing for silicon. So that. Draw SP. And then do electrons right here. Okay, we're almost done. Now we need to show more bonded electrons. Since we know this is a triple bond, what we're going to do is we're going to do something called bunny ears. So we do a bunny ear here, and a bunny ear there. And then we have one right here, and another one right here. And we're going to do the exact same thing for silicon. So right there. Okay. Here, let me erase this one because it doesn't look beautiful. Okay. Now, with these bunny ears, we're going to add an electron right here and an electron right there. I'm going to do the same thing for nitrogen. Okay, now I'm going to show you the bond between the two. So, we're going to have a bond right here and a bond right here. Okay, and we're going to do the same thing down here. Okay, and now let's just label all of our bonds. So the bond between the Si and the nitrogen, or the N, is going to be a sigma bond right here. And then this is going to be a half a pi bond, and this is going to be another half a pi bond. Here, let me erase that. And down here, we're going to have another half a pi bond and another half of a pi bond, which is going to give us a grand total of 2 pi bonds and 1 sigma bond, showing the triple bond that we created earlier. Now, we need to draw the brackets, showing that this compound is negatively charged. And then we're going to label its angle, which is 180 degrees. And lastly, since we know that both its molecular and electrical geometry are linear, we must write that. I hope you found this helpful. If you follow what I did, you'll for sure get 100%. Thanks for watching.